Welcome. This is the week 28 homework solution for IM 2. Here we have Monday, February 10th. We're going to ask to determine the domain, the range, and the end behavior for all these graphs. So let's look at number one first. Okay, so a couple of things we want to first look at is all the different properties. Okay, so domain is referred to as your x. So your x is going to be in between something and something. Your range, I'm going to treat that as purple in this case. This is going to be your y. It's going to be between something and something else. And you're also your end behavior. So end behavior, I'm just going to make this color. Okay. End behavior is when x approaches negative infinity. We call this the left arm. What happens to the y? Y is going to be something. And as x approaches positive infinity, y is going to become something else. Okay, so let's take a look at number one. All right, let's look at the domain. Let's look at the x's. Okay, so the x is going this way. Okay, right? Doesn't stop. Do you see how it keeps going forever? Goes towards negative infinity. And what about here? It looks like it's going this way, all the way to positive infinity. So you would say here the domain is from negative infinity all the way to positive infinity. So x is less than infinity, positive infinity, but greater than negative infinity. Looks like that because it goes all the way to the left, all the way to the right. Let's look at the range now. The range. Okay, the range is up and down. So let's look at how high it goes. Well, it looks like it goes all the way up to where? Positive infinity. And where does it go all down? Oh, it goes down here. It stops right here. What number is this? This is -1, -2, -3, -4, -5, -6. You see how it's right here? This is at -6. So your range, we start with the smallest value. The smallest value here is -6. And that exists. Does it include 6? So yep, that means, see, this means it includes 6 for the y. And it goes all the way to positive infinity. Okay? Goes all the way to positive infinity. And please note, it is just this symbol. There's no there's no equal to symbol here. Okay? Because it's just infinity. All right? Again, remember, when you write the inequality, it is from the smallest to the largest. Okay, that's why it's negative infinity all the way to positive infinity. All right, and let's do the end behavior here. So as x goes to negative infinity, right, as x approaches negative infinity, what happens to the y? It goes what? Up. So it goes to positive infinity, right? That's what happens when you go this way. What happens, x goes towards the positive infinity side. So watch as x goes to the positive infinity side. You should see my arrow. It goes to positive infinity for the y. All right, there you go. Again, I wrote the equation here, and you could also just use the sign of the leading coefficient and the degree. That's how we did it a long time ago in algebra 2. Okay? All right? So please keep note on this because I'm going to keep following this format. Okay? Here, you know what? Let me just grab this. Okay? And we can just use this for the other ones. Okay? All right. So let's take a look here for number 2. All right. So what color did I end up using? So red and purple. Okay. So the red, domain. Let's look at the domain. Okay, the domain, right? We have to look. Where's the arrow pointing? Oh, it goes all the way in what direction? Goes all the way what? We don't look up and down. We look left to right. Remember, the domain is only for your x, which is you only look left and right. So look left. Oh, look. It seems like it's going all the way to what? Negative infinity. And we go right. Goes all the way to positive infinity. So we would say the domain here is what? we could say the domain here is going from negative infinity all the way for x all the way to positive infinity. Okay. All right. So now let's look at. I made it purple. Let's look at the range. Okay. The range. Again, the range is for the y. Here we look. We look up and down. Okay. So let's look at the range. Okay. What is the lowest number that we see here? All right. Oh, it looks like. Does it stop? Do we stop here? No. Do you see how it keeps going down? Do you see the arrows pointing down? Oh, goes all the way to what? Negative infinity. And what about here? Whoop, it keeps going up, 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 all the way to what? Oh, positive infinity. So the range here goes all the way from negative infinity for y all the way to positive infinity. Okay? Doesn't stop. The y, right, doesn't stop here. It goes down. It keeps going down. All right, let's do the end behavior now. X approaches negative infinity. What happens to the y? Negative infinity for as x approaches negative infinity. That means we go to our graph and we move to the left. What happens to the y? Well, it goes down. So we will say it tends to negative infinity for y. Let's do the right arm as x approaches positive infinity. So we go to our graph. Now we move to the right. What happens to the y? Oh, goes up. So we will say y approaches positive infinity. All right, there you go. Okay, again, repeat the same process. All right, so let's do domain here. Domain isn't going to be in red. Domain, I look left and right. Oh, look, I keep going. I keep going. Does it stop? Nope. The arrow keeps telling me to keep going. Oh, goes all the way to negative infinity. Let's hear. What happens if I go right? Do I stop here? Nope. It tells me to keep going. I keep going all the way to positive infinity. So what is my domain? My domain here is from negative infinity for x all the way to positive infinity. What is my range? Okay. What is my smallest y? So, well, seems like it stops right here. Okay. Ooh, does that even look like 1? No, 1's right. Negative 1's right here. So this looks like it's like negative 0.5. You see how it's in between? Right here. Right? For y, all the way. Does it include it? Yes. So it includes negative 0.5 because look right here. This is negative 0.5. It includes it. It touches it all the way up. Wait, goes all the way up. That's a horrible line. So it goes all the way. It goes all the way up to what? Positive infinity. So y goes all the way to positive infinity. Okay, let's do our end behavior here. As x approaches negative infinity, what happens to the y? Okay, right here. We start here. We go left because it's negative infinity. What happens to the y? Whoop, goes all the way up. So it goes to positive infinity. Now we do the right hand side. As x approaches positive infinity, right? So we start here on our graph. Watch the arrow. Goes down, then all the way back up. So y is going to positive infinity. Okay? My infinity looks weird. There it is. Alright, so let's do this one now. This is number 4. Okay. You won't be given something like this, but I just want to show you this. Okay. So our domain, what is our domain? Let's look at it. Okay. We just look for our x's. Oh, yep, keeps going all the way to what? negative infinity, all the way to what? Positive infinity. So our domain, it's between negative infinity all the way to positive infinity. What is my range? What is the smallest y value that you see here? So look, we go down. You see how it stops right here? This is -1. So this is what? -2. Okay, it stops here at -2. Goes all the way up, 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 keeps going all the way to positive infinity. So we would say for the range, the smallest y is -2. It includes -2. That's why we have the greater than or equal to symbol. Here's the y, and it is going to be smaller than positive infinity. Remember, we cannot put the equal to. It cannot be equal to infinity. Okay, infinity goes on forever. All right. Here, let's do some end behaviors. As x approaches negative infinity, what happens to the y? Y, it goes down, 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 down. Where does it stop at? -2. So y approaches -2. As x goes to positive infinity, what happens to the y? Here's the line. We go to the right. What happens? Oh, it goes up. That means it goes to positive infinity. Okay. So look, do you see here? Do you see how it goes? So as x goes to negative infinity, it went to -2. Was right there. Then it goes to positive infinity, which is right here on the right hand side. Okay. So make sure you understand where that -2 is coming from. The -2 comes from the graph stopping here at -2. It does not go down. Okay, this is an asymptote. Okay, but again, you won't be given something like 4 yet, but I just want to make sure you see this. Okay, 5. Okay, let's look at 5. Let's look at our domain. Our domain is for x. I go here, here, here. Oh, I stop right here. This is at -1. So the domain smallest is -1. And let's go to the right. Where do I stop? Nope. Keeps going on forever all the way to positive infinity. So domain, it's at -1. It is at -1. That's why it's the less than and equal to for the x, but less than positive infinity. Okay, look, -1 all the way to positive infinity. That's the domain. Let's look at the range. Right? What is the smallest y value? Well, it stops right here. 0, 0. And it was that value. Okay? It doesn't go any lower. And what happens? Keep going, keep going, keep going, keep going. Does it stop? Nope. It keeps going, keep going, keep going. Look at the arrow. It keeps pointing up, 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 up. Up. This goes all the way to positive infinity. All right? Let's look at the end behavior. What happens as x approaches negative infinity? What happens to the y? Watch what happens when it goes to negative infinity. It stops. It stops. Technically, there is no end behavior here. This isn't wrong. As x approaches negative infinity, y approaches what number? To 0. Technically, this doesn't really exist. Okay, this really doesn't have a weird end behavior. So there is really no end behavior here. There is no left end behavior. Okay, because you can't really go to negative infinity because x cannot go to negative infinity. Okay, but you could say, is there a right end behavior? Yep, because look, you can go this way. So x, right? So this is the first one. What about the second one? X approaches positive infinity. Can you do that? Yep, look, it's going positive infinity. What happens as it goes to positive infinity? Y is going positive. So you could say this. So this is the only end behavior. This is the right end behavior. Okay? Yet you're not going to see something like this on the district test, but I want you to see this does exist and you can do this. You apply the same rule as what we do. Okay? All right, you will see something like 6, right? A parabola is fair game on the district as well as this district on the state testing. All right, so let's look at your domain. That's a bad domain. Let's look at domain. Okay. You should already get used to what the domain is for a parabola, right? What happens as you keep going left? It goes all the way to negative infinity. What happens when you go right? It goes all the way to what? Positive infinity. So, negative infinity, all the way to positive infinity. That is your domain. Let's look at your range. What is the smallest y value? -1, -2. See, it stops right there. -2. Notice we include it. Notice, look, we include it. We include it. It can be equal to -2. For the y, less than, how high does it go? Well, it keeps going, all the way to positive infinity. So we would say it goes all the way to positive infinity. Okay? Let's do the x behavior. As x approaches negative infinity, it's bad. As x approach, it's a bad arrow. As x, that's a better arrow. As x approaches negative infinity, so look at the arrow. What happens as it approaches negative infinity? This means you go left. Watch the arrow. Whoop, goes up. Y goes to positive infinity. What about as x approaches positive infinity? So it goes all the way. Whoop, goes up. So y goes to, but look like it goes to the right. What happens to the y? It also goes up. Goes to positive infinity. So these are arrows. Okay, these are arrows. Okay, good. Wow, this is so bad. Here's the arrow towards. There you go. Okay, these are supposed to be infinity symbols. All right, there you go. That's 6. Is that all? Is that all of it? Yeah. So a couple of things. Let me bring them all back together, and we're gonna look at the answer. We're going to look at a couple of answers because they share the same thing, okay? I want you to notice a couple of things, okay? The first thing I want to talk about, okay, is actually, so ignoring 5, you're not going to see something like 5, so I'm going to bring 5 down. So I'm going to bring 5 down, and I'm also going to bring 4 down, okay? Ignoring that. But look at the answer for 2, 3, and 6. I want you to look at it. Okay? One, 2, 3, and 6. These are all quadratics of some kind. Okay? Notice that all their domains here are the same. All the domains here goes from negative infinity to positive infinity. Domain here is the same. Domain's the same. Domain's the same. Domain is the same. The only thing that really changed is actually the range. Okay? So I do not know why a lot of you are freaking out with the domain, where the domain for a lot of your parabolas in your class just goes from negative infinity to positive infinity. Right? When you get to these are this is a log, and this is, I think this is a radical or one of them is this is exponential, this is log, or vice versa. But here, this is when the domain changes. Okay? But here, the domain for your parabolas in this class, the domain for your polynomials that you deal with in this class, the domain is just negative infinity to positive infinity. It doesn't change. Look at all your answers. Okay? So stop being afraid. The range is a little bit different, but you know how to do the range. You look up and down. And behavior, you should already know how to do it. But again, see me if you need help. Okay? So there you go. Those are all your Monday's solutions. Okay?